how does this work exactly? So you see the light shining on the ceiling and the vortices in the water generated by this moving piece here, they bend the light and make these nice black outlines, which then slowly separate as they drift down here. So now I want to find out first how exactly they did this. So there is a push arm apparently here, and something is pushing down on the water surface through a hole, and that hole provokes that the water goes in two little vortices. Nice. And the light is coming, from here below, through the tank. Let's see, when is the next vortex coming? Here it goes. And it's astonishingly black in the middle of the structure. And then after a bit of a turbulent time at the beginning of the tank, they really calm down and settle. And this one was quite turbulent. You saw here lots of waves, like smoke or so in the middle, reflecting the light. Very intense ones here. Sometimes they even collide and merge with each other. Or another one. Two black holes repel each other. Sometimes they are really slow and sometimes they are much faster. These are very calm. So now they say they got inspired to make this artwork by black holes, by wormholes. And indeed, you can kind of see an intense ring of light right around these black holes, just like the black hole horizon. Just now it reminded me of cells. Cells have a stronger cell wall around them, and that's the same here. These black spots, they always have a circle where there's more light around them. Needs to, of course. You have a black hole where photons are missing. The photons need to go somewhere, so it's pushed outwards to the edge of these black holes. I think there might be a relationship to how that is working with real black holes. This is what gives this ring of light around black holes. The real black holes, the bending of the light beams around it. They chose laser beams of different color, blue, red, green, and while the light is being refracted, the different colors appear at different locations. Sometimes they start decaying and then they find each other again. Seem to be little vortices being created to the side of the two big ones. I forgot to think about the wormhole, and obviously there is kind of a vortex wormhole here. you see how they created, they have this U-shaped hole in this plastic wall, and the water is much deeper than the edge of the U-shaped hole, which means that the vortex that is created is like a half ring. And this is just the creation of EPR pairs. So that is the core of a quantum cryptography experiment. I bet it has more. The two pairs need to be sent out to different receivers, and then the vorticity needs to be detected, and you need to have a component of randomness. If you look at analogies between EPR pairs, black holes, and this artwork, there's just one thing which I noticed right now, which is indeed true. If you have an EPR pair, often it's done with spin systems. Spins are just particles that rotate around their own axis. In an EPR pair, you can make it such that you have two particles and one spin points down and the other points up, and at the same time the inverse, the first one points down and the second one up. Yeah. And the first one points up and the second one down at the same time. And there's an analogy here to these vortices, because they necessarily spin in opposite directions. And if they would imagine they would spin in the same direction, then these vortices would just merge into one. And yeah, whereas here, because they spin in opposite directions, they can bounce off of each other and don't destroy each other. You could be looking out into a weird form of outer space, but you could indeed also just be looking totally at the micro world. Yeah, there's no scale bar in this artwork, and it could indeed be like both. And I guess that is one of the things. I mean, black holes can also have arbitrary sizes, and they, in this special theory, which was alluded to in the introduction, they are also an explanation for EPR pairs if they're really small. In a real EPR pair, you, as I said before, the vortices would rotate on both sides. I wonder if one could, I mean, here what they achieve is one vortex rotates in one direction, one in the other. And in a quantum cryptography experiment, you would then use the randomness of this to transport quantum information. So I wonder if one could convert this artwork into a demonstration experiment for quantum cryptography. For that, one would have to randomly change if the two vortices rotate clock and counterclockwise by quickly exchanging the plate through which the water here is pushed and making it one way or the other, perhaps with a barrier instead of a hole. And then one person would receive one vortex and the other person would receive the other vortex, and they would measure the rotation direction, which could be measured by overlapping it with yet another vortex of well-known vorticity, so they either destroy each other or they don't. Which is what you do if you build a quantum computer-based measure on fermions. Of course, black holes or EPR pairs are something that we only experience through our imagination, through science. We can't really see it with our own eyes. So it is related to our fantasy, and this music and this artwork here provoke fantasy to rise up, or to feel a little bit of magic